Hello everybody and welcome to the last video of this model. I'm Hafid Layouni and would like to use our last video to stress two important concepts we should have all in mind when assessing or reporting data analysis: effect size and sample size. In this course, we focused on p-values as a way of summarizing the results of our statistical test. At the end, our confidence of our working hypothesis being correct is function of how small our p-values is. This interpretation has a caveat we should keep in mind. P-values are highly dependent on the sample size. Let me show this using a fictitious example. Let's imagine we would like to compare two groups from a continuous variable. Let's imagine we repeated our experiment 4 times, each time increasing the sample size, and we were so lucky that we get always the same mean and standard deviation. If we calculated the t-value each time, being the difference always the same, the standard error of the difference will decrease when the sample size increases. Which makes sense, given we must have better estimation of the difference and hence less error. With the error being smaller and smaller, the t-value will increase and the p-value will decrease. Anybody not aware about the whole experiment may think the last analysis with n equal to 1000 is reporting high effect of the independent variable on the response one. However, the effect is clearly the same all time because we are dealing with the same data with different sample size. The fictitious example shows the importance and the need of an accurate interpretation of the p-value. Small p-value shows the unlikely effect of random chance and raises the need of other statistics to report effect size. The effect size is the intensity of the effect that the independent variable has on the dependent variable. There are several measures of effect size. In the case of two groups, comparisons, the formula is the difference between means divided by our best estimate of the standard deviation of our data. And it's interpreted as the number of standard deviations mean 1 is located from mean 2. Another measure of the effect size is R-square, proportion of variation explained, which means how much variation of the dependent variable the independent variable is able to explain. The interpretation of the effect size is highly dependent on the context. A slight improvement in a disease without any treatment is by sure important. However, a new treatment must exceed the previous one to be important. So, we have just realized that any difference may end up as significant, even though the effect size may be very small if the sample size is big enough. Let's look at the same problem from the other point of view. What may happen if the sample size is too small? Whatever effect will end up as non-significant if we are working with too small size. Hence, the importance of keeping in mind the statistical power concept when preparing our study. If the sample size is not appropriate to get evidence against a false null hypothesis, then we have a lack of statistical power and an increase of false negatives, also known as error type 2 or beta. Statistical power is defined as the probability of rejecting a false null hypothesis, which is actually our primary goal in any research study. Let's represent here the distribution of our test statistic under the null and the alternative hypothesis. If the null is false, hence the alternative is true, the expected value of the test statistic is the mean of the alternative. However, we may obtain any value around this mean. If the value is smaller than the critical value, we'll have a false negative. If it's above the critical value, we'll reject the null hypothesis. The power is then all the area located above the critical value, and this is the power. Usually, we should have a power equal or more than 80%. It's very easy to realize which factors may affect the power. The sample size is an obvious one. An increase in the sample size will increase the power. More variation implies lower power. High effect size increases the power. Using all these elements, we can calculate the sample size needed to reach a given power. A simple example will be the sample size needed to obtain a confidence interval with a given standard error. We can use the standard error formula to calculate the sample size needed to keep the error below a given value. The same can be done for a relative frequency or proportion. We have here an example on the confidence interval of the mean. We already have an estimate of the standard deviation based on previous study. According to this study, we can estimate a confidence interval telling us an estimate of blood pressure as 140 plus minus 5.6. What if we want to increase the precision in the next study to plus minus 1? Then we will use the formula of the standard error, which is standard deviation divided by the root square of n, and we get the appropriate n. Note that to increase the precision by 5.6 times, we need to increase the sample size 5.6 squared, which is 31 times. There are several tools available for the community to calculate the power. Researchers need previous estimates of standard deviation and effect size to calculate the power. Let me now summarize these concepts again. The first one is about the framework of classical statistics. False positives are part of the statistical game and cannot be avoided altogether. False negatives are results of the sample size and/or experimental design. My last point is to remind you on the importance of the effect size. If the p-value is small and the effect size is also small, it's very likely that the independent variable has a real but weak effect on the dependent variable, probably inflated by high sample size. If the p-value is high and also is the effect size, it may be worth to look to the power and increase the sample size. However, if the p-value is high and the effect size is low, the effect is weak and usually is not worth to keep working on it. Now, if your p-value is low and the effect size is high, congratulations! The result is significant and of practical relevance. You did a good job, both on identifying a true research hypothesis and to look for evidence to have it accepted. After this video, I hope you realized the importance of the effect size and the power analysis concepts, and you will apply both in your data analysis. I wish the course was very useful, help you to take profit of your scientific reading, and encourage you to enjoy the analysis of your data.